Welcome to Spaceverse, your portal to cosmic adventures. NASA's Voyager 1 probe, the most distant human-made object in space, is still sending fascinating data back to Earth, and it's got everyone talking. Since its launch in 1977, Voyager 1 has been on an incredible journey, uncovering jaw-dropping secrets of the cosmos. From revealing a massive storm on Jupiter to discovering rings around Saturn, this legendary spacecraft has consistently amazed us. But now something truly strange has happened. Voyager 1 has made a discovery so puzzling that even scientists are scratching their heads. The data from the system controlling the spacecraft doesn't seem to match what Voyager 1 is actually doing out there in space. What could this mysterious discovery mean, and where do we go from here? Join us as we dive into this cosmic conundrum and explore the latest twist in Voyager 1's epic adventure. The universe is full of surprises, and we're about to uncover another one. Voyager 1's unexpected signals have left NASA's team scratching their heads. For 47 years, Voyager 1 has been journeying through the vastness of space, venturing far beyond our solar system into the mysterious realms of interstellar space. Despite being an incredible 15 billion miles away from Earth, this remarkable probe continues to operate, receiving and executing commands from NASA and transmitting valuable scientific data back to us. However, a puzzling issue has recently emerged with one of its most critical systems, and it's serious enough to make anyone concerned. The system in question is the Attitude Articulation and Control System, which is crucial for maintaining Voyager 1's orientation in space. It keeps the spacecraft's high-gain antenna pointed toward Earth, ensuring that data can be sent back to NASA. But lately, the data from the AACS doesn't match what Voyager 1 appears to be doing. Although the probe seems to be functioning normally, the information from the AACS is coming back as random or impossible to interpret. The biggest challenge in addressing this problem is Voyager 1's immense distance from Earth. Since the spacecraft is in interstellar space, it takes 20 hours and 33 minutes for a signal to travel one way, meaning any communication with Voyager 1 requires over 41 hours for a round trip. Despite the delay in communication, the Voyager 1 team has determined that the AACS is likely still operational. The irregular data readouts from this system have not triggered the spacecraft's safe mode, a protective state that limits functions to essential operations, allowing engineers to troubleshoot any potentially threatening issues. What's even more intriguing is that the signal from Voyager 1 remains as strong as ever, indicating that the antenna is still correctly aimed at Earth. The team is now investigating whether the AACS itself is producing incorrect data or if another system might be causing this anomaly. Understanding why the information from this instrument doesn't align with Voyager 1's actual operations is critical. As they work through this mystery, the team studying Voyager 1 is focused on pinpointing the cause of the problem. Until they do, they can't predict whether it will affect the spacecraft's ability to collect and transmit scientific data. This uncertainty was highlighted in a 2022 NASA release. Suzanne Dodd, the project manager for both Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in Pasadena, California, noted that such mysteries are expected at this stage of the Voyager mission. Dodd explained that the spacecraft is nearly 45 years old, far exceeding the mission planner's expectations. She also emphasized that Voyager 1 is now navigating interstellar space, a region filled with intense radiation where no other spacecraft has ventured. This environment presents significant challenges for the engineering team managing the mission. Despite these challenges, Suzanne Dodd is confident that her team will find a solution to the problem with the Attitude Articulation and Control System. If they can't pinpoint the exact cause, they may need to adapt. Dodd mentioned that if they can identify the issue, they might fix it by updating the software or switching to a backup hardware system. Over the years, Voyager has stayed operational by using backup systems when needed. For instance, in 2017, the spacecraft successfully used thrusters that hadn't been active since the 1970s during its planetary encounters. These thrusters, inactive for 37 years, still worked when called upon. Given the probe's age and their decreasing power generation each year, many subsystems and heaters have been shut down to conserve energy for the most critical systems and scientific instruments. Despite the current issue with Voyager 1, it's worth celebrating one of its most historic achievements, its visit to Jupiter. When Voyager 1 reached Jupiter in 1979, it made several groundbreaking discoveries that reshaped our understanding of the giant planet. One of the most surprising findings was that Jupiter has a ring system. Until then, scientists believed that only Saturn had rings. Jupiter's rings are faint and composed mainly of tiny dust particles, making them difficult to see from Earth, but Voyager 1's close-up images revealed them clearly. Voyager 1 also conducted a detailed study of the Great Red Spot, a massive storm on Jupiter that is larger than Earth and has been raging for at least 400 years. The spacecraft's photos provided a detailed look at the red spot, helping scientists learn more about its structure and behavior. The storm features strong winds moving in opposite directions around its center, creating a complex and dynamic weather system. Beyond the rings and the Great Red Spot, Voyager 1 discovered many other fascinating aspects of Jupiter. It captured images of the planet's clouds, revealing numerous smaller storms, lightning, and even auroras similar to those on Earth. These observations help scientists better understand Jupiter's atmosphere and how it compares to Earth's weather systems. After its exploration of Jupiter, Voyager 1 continued its remarkable journey through the solar system, reaching Saturn in 1980. This phase of the mission was equally captivating, as the spacecraft made several groundbreaking discoveries about Saturn, its moons, and its massive ring system. One of the most intriguing findings by Voyager 1 was the discovery of new moons around Saturn. The spacecraft identified several previously unknown moons, adding to the ever-growing list of Saturn's natural satellites. These moons varied widely in size and composition, enriching our understanding of Saturn's complex moon system. Voyager 1 also conducted an impressive and detailed study of Saturn's rings. Before this flyby, scientists were aware of Saturn's rings, but Voyager 1 provided unprecedented close-up views and critical data about their structure and composition. The spacecraft revealed that Saturn's rings are made up of countless individual particles, ranging in size from tiny grains to large boulders. These particles orbit Saturn in a vast and intricate system of rings, which Voyager 1 showed were not solid but composed of numerous individual ringlets, gaps, and divisions. The observations demonstrated that these features result from the gravitational interactions between Saturn's moons and the ring particles, creating complex and ever-changing patterns within the ring system. Voyager 1 also captured stunning images of Saturn's moons, including its largest moon, Titan. These images offered invaluable insights into the geological features and surface characteristics of Saturn's moons, shedding light on their origins and evolution. But Voyager 1's exploration didn't end with the physical features of Jupiter and Saturn. The spacecraft also took a closer look at two of the most intriguing moons in the solar system, Jupiter's Europa and Saturn's Enceladus. And you won't believe what it discovered: Jupiter and Saturn's biggest moons. Imagine moons with hidden oceans just waiting to be discovered. That's exactly what's got scientists buzzing about Jupiter's Europa and Saturn's Enceladus. Europa, one of Jupiter's largest moons, has been a hot topic for a while. Why? Because it might have a secret ocean hiding beneath its icy shell. Galileo's images taken during its mission from 1995 to 2003 revealed some amazing features on Europa, like cracks and ridges, that suggest the ice might be cracking open due to Jupiter's powerful gravity and interactions with other moons. It's like the moon has its own secret tectonic drama going on underneath. What makes Europa even more exciting is the possibility of life. Where there's liquid water, there's a chance for tiny, mysterious creatures to be swimming around. Scientists dream that Europa's ocean could even have hydrothermal vents, similar to those on Earth's ocean floor, which could be the perfect place for life to flourish. And let's not forget about Enceladus, Saturn's icy moon, which has its own amazing secret. The Cassini spacecraft spotted spectacular jets of water vapor shooting out from Enceladus, hinting at an ocean beneath the ice. These geysers aren't just spewing water, they also contain organic molecules, the essential ingredients for life. Plus, Cassini found signs of hydrothermal activity on Enceladus's seafloor, suggesting that something incredible might be happening under the ice. The discovery of hidden oceans on Europa and Enceladus has scientists buzzing with excitement about the possibility of extraterrestrial life. These moons are like treasure chests of potential life within our solar system. NASA has some thrilling missions lined up to investigate further, like the Europa Clipper, which will delve into Europa's mysteries. There are also plans to send more missions to Enceladus to uncover what's happening beneath its icy surface. But that's not all Voyager 1 has revealed about Jupiter and Saturn. NASA has recently shared more jaw-dropping details about these planets, and it's clear that Voyager 1 is far from finished uncovering their secrets. The spacecraft continues its epic journey into the vastness of space, unstoppable and ever-revealing. Voyager 2, Voyager 1's twin, is also thriving in the realm of interstellar space. It's currently 12.1 billion miles or 19.5 billion kilometers away from Earth. For comparison, Neptune, the most distant planet from Earth, is at most 2.9 billion miles away. Launched in 1977 alongside Voyager 1, both spacecraft have far surpassed their original planetary flyby missions. Today, they're the only spacecraft sending back data from the vast, unexplored reaches of interstellar space. Their observations are providing invaluable insights into the heliosphere, a vast bubble created by the Sun that extends well beyond the planets. This information is crucial for scientists as they explore this distant and largely uncharted region of space. Voyager 2 has been making waves with some truly mind-blowing discoveries since it dove into interstellar space. On November 5, 2018, Voyager 2 achieved an incredible milestone by crossing the boundary of the Sun's bubble-shaped zone, known as the heliosphere. This momentous event made Voyager 2 the second human-made object to venture into the vast expanse beyond our solar system. Scientists are now thrilled to share the exciting first data from this historic journey. But here's the twist. Even though Voyager 2 has crossed the heliosphere's edge, it's not quite out of our solar system yet. The actual boundary of our solar system is way out in the Oort cloud, a mysterious, icy region far beyond the planets. Voyager 2 is expected to take about 2,300 years to reach the inner edge of the Oort cloud and around 30,000 years to make its way through the whole thing. On November 4, 2019, the journal Nature Astronomy published 5 thrilling studies revealing what Voyager 2 has discovered. Scientists have pinpointed a fascinating boundary where the hot solar wind from the Sun meets the cold, dark interstellar space. This boundary is called the Heliopause. By analyzing Voyager 2's data, scientists confirmed that it crossed this boundary on November 5, 2018. On that date, the number of solar wind particles around the spacecraft dropped dramatically, proving that Voyager 2 had officially left the Sun's protective bubble. So, Voyager 2 is out there, cruising through the cosmic void, and we're just beginning to uncover the secrets it's sending back from the edge of our solar system. Recent studies have confirmed that Voyager 2 entered interstellar space on November 5, 2018. This remarkable event, which occurred over 11 billion miles from the Sun, took less than a day. As Voyager 2 crossed the Heliopause, it transitioned from the hot, sparse plasma of the solar wind to the cooler, denser plasma of interstellar space. This shift indicates a balance between these regions, with the density helping to equalize pressure differences. Voyager 1 also made the leap into interstellar space in 2012, but due to damage to its plasma instrument, it couldn't provide complete data on its crossing. From the combined data of both Voyager 1 and Voyager 2, scientists discovered that particles from the solar wind and interstellar wind mix and flow across the boundary. This interstellar wind is produced by stars that exploded as supernovas millions of years ago, creating a complex interface between the heliosphere and interstellar space. Voyager 2's crossing revealed that the heliosphere has a clear, smooth boundary between different types of plasma. Additionally, astronomers detected a strong interstellar magnetic field more intense than what Voyager 1 observed. This magnetic field originates from exploded stars, sending out material and magnetic fields. The way the Sun interacts with interstellar space is intriguing because when it releases shock waves, these waves travel through the heliopause into the interstellar medium, causing disturbances similar to those from supernova shock waves moving through the space between stars. The early data from Voyager 2's crossing into interstellar space is providing scientists with crucial insights into the space between the Sun and the interstellar medium. This information is particularly valuable because scientists believe other stars might have similar features. By examining the data from Voyager 2, astronomers can gain a better understanding of other star systems, especially when they study stars with planets around them. Comparing Voyager 2's findings with those from Voyager 1's crossing helps identify similarities and differences, but scientists are eagerly anticipating the launch of another interstellar probe from NASA to deepen our understanding even further. Think of the heliosphere as a cosmic windsock. Scientists are hoping for a probe that can travel along the sun's wind's tail, extending the solar system's boundary. This would provide more information about how the heliosphere interacts with interstellar space. Voyager 2 hasn't just been making headlines with its interstellar journey. Like its twin Voyager 1, Voyager 2 also made significant discoveries about Jupiter. In 1979, it spotted a small moon called Adrastia orbiting Jupiter. This discovery was groundbreaking because it was the first time a moon was identified using spacecraft images rather than just Earth-based telescopes. Named after a figure from Greek mythology who cared for Zeus, the Roman Jupiter, Adrastia's discovery added another fascinating detail to our understanding of Jupiter's moon system. Adrastia stands out because it is one of the few moons in our solar system that orbits Jupiter faster than the planet rotates. Positioned right on the edge of Jupiter's main ring, it's believed to be a key contributor to the material that forms these rings. Despite being observed by the Galileo spacecraft in the 1990s, there is still limited knowledge about Adrastia's composition and appearance, other than its size and the fact that it always faces Jupiter in the same way. David Jitt and Edward Danielson first discovered Adrastia while examining photos from Voyager 2 on July 8, 1979. In these images, Adrastia appeared as a tiny dot. It wasn't until 1998, when the Galileo spacecraft provided clearer images, that scientists gained a better understanding of its shape, though the details remain somewhat fuzzy. Named in 1983 after a nymph from Greek mythology, Adrastia was the daughter of Zeus and Enki. In 2016, the Juno spacecraft arrived at Jupiter, equipped with a camera named JunoCam. Although Juno's main mission is to study Jupiter itself rather than its moons, it might still capture some images of moons like Métis and Adrastia, though these photos might not be very detailed. Adrastia, the smallest and second closest inner moon of Jupiter, orbits at about 129,000 kilometers from the planet's center, approximately 1.86 times Jupiter's diameter. It resides on the outer edge of Jupiter's main ring and follows a nearly circular orbit with only a slight eccentricity of about 0.0015 and a minimal tilt of 0.03 degrees relative to Jupiter's equator. Adrastia is tidally locked, meaning it rotates at the same rate as it orbits Jupiter, always showing the same face to the planet, similar to how the moon always faces Earth. Its longest side faces Jupiter, which helps it stay stable. Adrastia's orbit is gradually decreasing, bringing it closer to Jupiter over time, and it might eventually collide with the planet. However, if Adrastia had a density similar to that of another moon, Amalthea, it would likely be too close to Jupiter to remain intact. Since Adrastia hasn't disintegrated, its orbit remains slightly farther out than expected. Voyager 1 and 2 were initially expected to last just 5 years, but they have surprisingly continued to operate for 42 years. Given that the space age was only 20 years old at the time, it was difficult to imagine these spacecraft lasting so long. This incredible achievement is largely due to the engineers who have kept these twin spacecraft functional. They have developed new plans to ensure Voyager 1 and 2 remain operational, allowing scientists to keep receiving valuable data from the distant reaches of space. Maintaining power for Voyager 1 and 2 is a major challenge as they're over 11 billion miles from the Sun. The spacecraft need power for scientific instruments and heaters to prevent freezing. With their power systems now producing 40% less power than at launch, fuel must be carefully managed to keep their antennas pointed toward Earth. Both spacecraft's thrusters are also wearing out, but Voyager 2 will activate thrusters last used in 1989, while Voyager 1 had a similar update in 2017. Voyager 2's cosmic ray instrument, despite a drop to negative 74 degrees Fahrenheit, continues to send data exceeding its tested operating temperature. Communication with the spacecraft takes about 16.5 hours for data to travel back to Earth. Engineers have implemented a new power conservation plan to keep both spacecraft operational for a few more years. The valuable data they continue to provide supports NASA's upcoming Interstellar Mapping and Acceleration Probe mission. The ongoing success of the Voyager missions highlights the ingenuity of their design and the dedication of the engineers and scientists who support them. As Voyager 1 and 2 continue their journey into interstellar space, there is hope for more discoveries. Even if they lose power and stop communicating, they'll drift on with their golden records, time capsules of Earth's achievements. Their legacy will inspire future explorers and showcase humanity's curiosity. And that's it. Thanks for watching Spaceverse. As Voyager 1 and 2 journey through interstellar space, their golden records and discoveries spark our curiosity. What do you think they'll find next? Drop your thoughts in the comments, like, share, and subscribe for more cosmic updates. See you next time.